morning, everyone. Welcome to day two, excuse me, of the Airships to the Arctic Conference. It's a pleasure to have you here. I know that many of you are joining from yesterday, and today we're going to see the airships that can make the solution to some of the problems that we heard yesterday. For those who are just joining us today, welcome to the sessions. We are going to have our speakers in the morning, four of them on the airships themselves, the leading airship companies, and then we will follow with the regulatory conditions that are coming up. With that, I'd like to point out that this is a celebration of the 20th anniversary of the Airships for the Arctic. Our first conference was here some 20 years ago. And we have, in fact, on the program, people who were actually there at that same time with me, which is very pleasing to see. But we can also see how the industry has grown very substantially in that time. And of course, the prospects for future growth are very good. I'd like to thank the University of Manitoba for hosting this in conjunction with Isopolar and the organizing committee. And with that, I would now like to turn it over to our first chair, Ross Prentice, who will introduce our speakers for the morning.
Hi, everybody. My name is Ross Prentice. I'm the CEO of Buoyant Aircraft Systems International, and I am also a logistics technology consultant. I've been working in a variety of roles throughout the last decade, involved directly with airship technology, and I'm very excited about the possibilities for positive change and expansion of access that airships represent for us. It's my privilege to chair the second session of the conference, and I just want to mention a couple quick things before we get started. Barry mentioned as well, too, if there's questions throughout the session, if you could direct them, please, to the Q&A, and we'll do our very best to get answers back to you for those questions. I'd also encourage lively discussion in the chat or also messages of encouragement throughout the event for our presenters as well. As we have limited time for each presentation, I'm going to try to keep the introductions brief and hoping to allow as much time as possible for discussion and questions afterwards. So with that said, I'm pleased to introduce our first speaker, Arnaud Toulouse of the Flying Whales Company. Arnaud graduated from the École Polytechnique in France and the Georgia Institute of Technology in Atlanta with a Master's of Science and Aerospace Engineering. He joined the airship world in 2018 as program manager at Flying Whales before being nominated CEO of the Flying Whales subsidiary in Canada, Flying Whales Airships Quebec Incorporated. Today, Arnaud will discuss the Flying Whales airship LCA 60T and a planned lighter than air cargo transportation service for the Canadian North. This novel airship requires no infrastructure for operation and will ultimately integrate a hydrogen-fueled propulsion system producing net zero emissions. Arnaud, the floor is yours.
Thank you, Rose. Hello, everyone. I hope you hear me well. I'm very happy to have the opportunity to present Flying Whales while I'm traveling. So I will then run to my airplane, but it's okay. So let's do it. So we will start with a short video, which shows our solution in action. Might be some music as well. And as a good French company, we always like to start with some poetry. So it shows actually where we started. We started in the forest with all the complexity of being able to have a good exploitation of a forest. And so there you will be our solution. So the way transforming into our airship. So we are developing a rigid airship with a long cargo bay that you just saw. So the cargo bay can hold, it's actually the length of a football field. And we grab the loads for this application for which we come from, let's say. We grab directly the loads while hovering up to the cargo bay. And then we transport it straight to the sawmill and we go back and we do it again. So here you can have an application which is very interesting when you have no airport or let's say no big water airport for such a ship. So we can take directly the containers and straight to the delivery area. So here is another application that is today done by helicopter, having a lot of different difficulties for assembly. the blades as a, well, I will show you this after. So while you all know the good opportunities to have a very low consumption with an airship, thanks to the helium acting for the lift. So here is an application in the French island, Polynesia Island, was buried the garbage because they don't have any access to a big port. Obviously, those applications are very interesting when you need immediate rescue. Thanks to our solution, we don't need any infrastructure. So by definition, when you have an earthquake or everything is broken, so without any infrastructure, you can still use airship. And also in area where actually there is no infrastructure, and that's where we believe we can help the cargo with airship solution. So here you can see, well, actually this is a whole solution with the air dock. The air dock is capturing the airship, and so the airship never land, just floating on the air dock, so we can put it back to the hangar, being protected from the wind and everything. To the weather. Okay, so let's start. So yeah, we always start with our raison d'être to explain where we come from and what we would like to do. We are not building an airship for building an airship. We just realized that airship was the best solution to unlock territories that are remote without any infrastructure, and airship can help to reduce a lot the environmental footprint of the cargo in a different way, either by the emission. So what is our adventure? We come from the wood, as I said, and it's actually our president who had a discussion with the president of the ONF. ONF is the French office, is a French agency taking care of the forest in France. And we have a big issue in France that the wood is the second contribution to the deficit in France, the balance. But we have one of the largest forests, so we need to find solution to remote woods from remote forest, and it ended up having as airship to be a very good solution. So that's where we start, and from that point we then work on the solution of the architecture, and now we have plenty of different application more than wood. So here you can see where we are today with a large industrial consortium working with us to develop this solution. So you can see there is a lot of different companies. Some are very famous and very big, such as Pratt & Whitney, Honeywell, Safran. But we also have mid-sized companies in the industry, not necessarily in aerospace, but this make a very good mix of good partners that are for most of them risk-sharing partners, meaning that they are embarking on this journey with putting their own risk due to the interest of the solution and the work we are doing together. So where we are today, what is Flying Whales? Flying Whales, we today have two companies, Flying Whales, which is with part from Quebec and part from France, and Flying Whales Quebec, a subsidiary which belongs to Flying Whales and the Quebec government. So Quebec government entered into capital in 2019, and on the French part, we have a mix of public actors, so like Office National des Forêts, as I said, which is actually our first customer, but also shareholder. We have La Région Nouvelle-Aquitaine, who will build our final assembly line, but also big industrial companies such as Bouygues Construction, which is very interested to all the construction of our infrastructure, but also Aéroport de Paris, which is the biggest airport actor, one of the biggest in the world, and Air Liquide, which is obviously very interested to be a supplier to us for the helium, and also financial investor. And for such a big development, we need to rely on public support. And that's why we added on the bottom right the different subvention and financing we obtain from public agencies such as BPI in France, the Ministry of Economy in France, but also in Quebec with the Ministry of Economy, which started this year and the year before to support the restart of the industry post-crisis. So here you can see a little bit of our timeline. So we passed this year the preliminary design review at the airship level. We've been working on our development, let's say, since 2016, 2017. We had a first milestone and second one, and now we are closing the third one, the PDR, to go up to the CDR in 2023, that will allow to build our first airship. So the first assembly line will be in France, close to Bordeaux, and the construction of the assembly line will start by the end of this year to allow the production of the first LCA that will fly in late 2024, beginning of 2025. At the same time, we opened our subsidiary in Montreal. So I'm now based in Montreal, even if I'm traveling in the US right now. And in 2025, we aim at building our second production line which will be in Quebec. We have different sites, but we need to enter into details to find the best one. And in parallel, we are working with obviously certification, but I will let Thibaut explain very well where we are today and what is our approach. So briefly, our characteristic is that we are able to transport 60 tons while hovering, and the hovering part is one of the best interesting part of our solution. Our dimension is quite huge as every airship, so it's 200-meter long, 50-meter wide, but most importantly, we have a cargo hold which is as big as a football field, so it likes a lot of room to take very big parts that cannot be transported by any other matter. We have a propulsion which is all around the airship to have a good maneuverability, and 14 helium cells. So this is not pressurized, which gives a lot of safety, which helps in safety. We do have a lot of different market opportunities. So I talked about the wood and the way we could sustainably harvest forest. So we always explain that it's not removing wood from the forest, it's just taking less than what the forest is growing. So the forest still continue to grow. And thanks to the airship, we can take some wood everywhere in the forest and not only close to the road or having to build roads to go and take wood. We have a big interest with the power market. So as of the wind turbine component, which are a big nightmare to transport, because obviously we want to have a wind turbine very far and where the area are windy, so definitely not accessible and without any infrastructure. Yeah, I will go quite quickly so we can speak about the Canadian part. But we also have a special cargo transport for remote areas, as I said, so we can bring very big components to help the infrastructure develop. We have a lot of interest also in the industrial market, so you can see with a little picture an application very interesting we are working on with Arianespace to be able to take the launcher in the sea after the launch. And I talked during the video about the humanitarian and aid for disaster relief, as your ship is a very good solution when the infrastructure are not operating anymore. So flying walls in Quebec, why are we sending up a subsidiary in Quebec? Well, actually, the government were very interested listed by the solution as Canada is one of the best area where airship would bring a big deal, because there is a very interesting and rich, we have such good partners there. So in Canada, we identified four major area where we could bring our values. So the first one is to mitigate the consequences of the climate change. The second one will be to help remote communities and improve their quality of life. And the third one will be to access resource, but in a sustainable manner, and then to support the development of renewable energies, so such as the wind market, as I said. So we can see year after years, and Barry is explaining very well what is happening in the big north of Canada, having a very big difficulties with the ice road that are having less time during the years that can be operated, risk issues while the climate is changing, and the cargo, the airship cargo will simplify a lot of logistics. It will reduce time, cost, and the risk that is today facing with the road. So yeah, we can see all the different communities that are in extremely remote areas. And we identified a use case which is really interesting to look at. It's a case of the communities in Kashishiwan, which is having year after year more flooding due to the climate change. So they decided to move these communities 20 kilometers away. So the cost was estimated to be between 500 to $800 million, which is well, extremely high for the size of this community. We worked a little bit on this case to identify what would be the gain of having an airship such as our to do this to help to relocalize this community, and we ended up having an estimated cost of only a fraction of what was estimated of about $20 million. Moves that can be done very quicker within 6 months. So this is a kind of application that will really help as beginners. So as we are talking about the remote communities, there is just only some regular supplies that are very difficult to provide up to the north, and that are done through airplane today. So when you use an airplane, you are arriving in an airport which is still not the communities. So logistics is very difficult, which makes the products extremely expensive. So this will help a lot with airship, as we can transport some houses in kit, for example, or fresh produces directly to the communities. And this is a very interesting application we've been working on since a year now, but which was not our first thing. We discovered that recently, that we would have a very interesting application transporting an hospital that could help communities not having access to medicine today, being able on a regular basis to have the hospital coming to them. So it helps in a way that you won't have to build as many hospitals as communities. You just need to build one. You will always have a good operating medical systems with good maintenance. So you don't have any issues of broken stuff and so on. And also for the people to plan all these visits. So this is very interesting where you have spread communities in different areas. So exactly where what is done in most of Canada. So accessible resource in sustainable manner. I talked a lot about the wood in the Canadian forest are well as exploited as it could be due to their growth. And so this makes a big application for our airship in Canada, and also while preserving the forest. So there is a Quebec plan, which is called the Quebec Caribou Recovery Plan, to help the caribou still you disturb the local the animals, and going by the air can help minimizing our footprint. But when we speak about resources, there is also in the far north the mineral resources, and there is difficulties to access, which makes sometimes the mining to be shut down because the costs are too expensive. So thanks to that, we could either develop the economy locally and provide while providing the communities basic stuff to live. So so mining is obviously a very interesting application to us. And the last one is the power market. In the video, we were showing the way we transport towers. So today it's done by helicopters. So it's several rotations of helicopters with people having to work up into the tower, which makes it very dangerous. So we can do it very efficiently with a lower cost and easy operation. And as for the wind blade, well, when the blade is not bigger than our cargo hold, we can take inside the cargo, which makes it very easy and cost effective. And after, when you have like blades bigger than 100 meters, we can still carry it under sling, and going straight, it helps a lot the installation in Canada. And there is a annual growth of 16% per year, which makes a lot of work to be done for transport those wind turbine. And also, there is not only new installation; it's a lot of repowering because the life cycle of a wind turbine makes it a lot of activities at time, recurring activities. And to finish this presentation, we will talk a little bit to how we will improving the solution in the future. So airship is extremely interesting as the emissions and the energy consumption is very low at the ton compared to other aircraft or helicopters. But still we are using petrol to convert and to create our electrical system up to the motors. So that's why we are working on a solution which will be totally sustainable. So so on the top left, we talk about the revolution as for the green impact. Each base, which is not smaller, a lot smaller than an airport, addresses actually about 1 million square kilometer of operations, and we don't need any infrastructure in the operation, only the base. So helium provides a lift, which makes in average 80% less emissions than a helicopter, and we'll explain on the top right the equivalent emissions for an helicopter at the ton. And as I said, we continue to improve. So by 2024, we will get using a sustainable aviation fuel, but the ultimate goal is to be combustion free power generation by hydrogen, which makes zero emission in operations. So how we do that? We actually will have an architecture today that makes it possible to switch our turbo generator by a fuel cell without needing to change the downstream network, which is electrical propulsion distribution, and the propellers, which is already electrical propellers. So that's where we are today, showing us the interest of having the airship as for remote operation, the interest of having airships as for reducing cargo emissions in operations, and the way we will strive to have a zero emission in the end. So thank you very much. I hope you were not too disturbed by the airport noise, and I hope I was enough clear in my explanation.
It's perfect. Thank you very much, Arnaud. I see there's a few questions here in the Q&A. If we have a couple minutes, we can answer possibly a couple of them. Several are asking about the ballast exchange and the nature of the way that would operate for unloading heavy objects from the aircraft. Are you able to explain a little of the ballast exchange?
I think Thibaut will be able to answer, as I have a plane. The plane is boarding now, so certainly. I definitely need to go. I'm very sorry about that.
It's no problem. All good. Yeah, we'll look to Thibaut to answer the questions in the Q&A then. And again, thank you so much for your presentation, and have a safe flight.
Okay, thank you very much. Welcome.
So then up next, we will have our second speaker, Mike Durham of the Hybrid Air Vehicles UK. Mike is the Chief Technical Officer of Hybrid Air Vehicles and a graduate of Loughborough University with a degree in aeronautical engineering. Mike has over 30 years experience developing lighter-than-air technologies, and he became the Chief Engineer of HAV at its inception, as well as the Technical Director in 2010. He leads the technical development of all HAV's products, and Mike will be talking to us today about HAV's progress on the Airlander family of hybrid aircraft, as well as the production and type certification program for Airlander 10. Mike, the floor is yours.
Thank you very much, Ross. Let's try and do the technically bit and share the screen properly. Good. There we go. Okay. Well, let's we'll call that a vague success. This is the trouble with letting a CTO anywhere near technology. It's never going to win first time. So good morning, good afternoon, everybody. My first job is to apologise. Originally, Tom Grundy, our CEO at Hybrid Air Vehicles, was going to be talking to you. He's not able to be here due to other commitments. He's out chasing finance, amongst other things. So that means you've got to listen to an engineer talking about the sort of commercial and economic cases for Airlander and, you know, our path to market. So apologies again in advance, as I'm likely to diverge into technical stuff at the first opportunity. So let's see how we go, eh? So we were incorporated back in 2007, but many of us have been doing it for a long time prior to that. We were born out of airship industries back in the 70s. But really, HAV came into being solely focused on developing hybrid aircraft. We were lucky enough to win the Lenvey contract with Northrop Grumman back in 2010. It gave us a huge opportunity to build a full-size prototype, albeit for quite a specific operational need. And we got that one built in less than 2 years, flew it out of Lakehurst in 2012. And then with sequestration and so forth, we had the opportunity to buy that aircraft from the US military. We brought it home to the UK in 2014. And we did a bit of tweaking and modification to it, shall we say, 400 or 500 mods. And it evolved into effectively the prototype for the Airlander 10 product. And then we took it flight testing for a year or so. So what is a hybrid aircraft? We sort of see it as merging the best aspects of lighter than air technology and conventional airplane technology. We're trying to produce an efficient and commercially viable transport device, a truck of the air, if you like. But just to be clear right up front, we don't see hybrid aircraft as replacements for airships or airplanes or helicopters. There are right roles for all these aircraft types. And we see each has got its role to play. And you know, that's sort of going in position. Equally, we also see some of the competition for Airlander coming from surface transportation Certainly, as you go to the larger variants of our vehicle, we see us competing with ships and trucks on some routes. But again, there were, this isn't a one-size-fits-all sort of solution. So HAV's goal is to produce an aircraft that, via its LTA heritage, produces a low-cost means of transporting stuff. Okay, at modest speed, but the upside, significantly reduced CO2, if not zero CO2, when compared to existing aeroplanes and other transport means. So over the last 3 years or so, we've been putting a lot of effort into optimizing not just the technical product, but the return on investment for operators. We've been working with many potential customers, trying to make sure we get the mix of vehicle technology, which obviously is the center of everything as far as I'm concerned, but mixing that right with operational cost and making the right choices about size and all of this sort of stuff. So we've been very much engaged with a large customer base, talking about what's the right product to use. It's created a set of key user requirements, as we call them within HAV, and fundamentally that's what we've then taken our learning from the prototype aircraft and melded that with those user requirements, and we end up with the Airlander 10 production vehicle. I think one of our biggest challenges that we've seen with LTA, and I've experienced quite a bit of this over the many years, is making sure we get the ground operational aspect of LTA right. There's no doubt, once you're up in the sky, it's pretty straightforward. But the ground interface piece, that's where the challenges can be. We're trying to get ourselves away from having to have a mast or a large amount of ground infrastructure at every location we visit, and this is part of why we've gone the hybrid route. It gives us a wide spaced, stable landing system. It means that we can put it down on a multitude of surfaces and so on. And the helium is a great thing in every respect bar one. If only you could turn it off when you wanted to. That's the biggest problem we face as an industry. So, and again, we've developed Airlander to try and help us with this, making us a bit more like an aircraft, so that we're only sort of 80% reliant on the helium piece. It gives us a slightly wider operating envelope to be able to work to, without having to get into gas compression or ballasting of other sorts. It doesn't solve the whole problem. Airlander is not a complete solution to it. We really do need a backhaul on freight journeys and so forth. But in the main, from our conversations with potential customers, there nearly always is a backhaul of some form, even if it's only 60 or 70% of the weight fraction. It still helps us. So that's a key thing for us. The pictures on the screen just show the sort of various steps that we've gone through in terms of scale model stuff, and then getting Lemvy flying in the top right picture, and then converting it into Airlander back in the UK. But the roles we're currently focused in on, and this is purely about Airlander 10 today. I'll talk a little bit to our expansion plans in due course, but really for Airlander 10, it's a bit on the small side for a full up freighter. We've talked to customers, and there are definitely niche markets for 10 to 12 tons of freight over 1,000 miles. But really, you want economy of scale, and that's where we drive to with our bigger products for the freight side of things. What we have picked up from customers, they are so keen to be able to operate from water. There's a lot of enthusiasm for getting away from having to have, well, there's a lot of enthusiasm getting away from airports to start with. But if we can get away from finding greenfield sites or landing on rocks and stuff, water operation is definitely a flavour of the month, shall we say, at the moment from the customer base we've seen. And it's that enables us on some of the configurations for Airlander 10. So passenger mobility, we've been looking at sort of the 100-seat area of city to city passenger movement. And there's no doubt there's some real enthusiasm out there to be able, not necessarily to get from city centre to city centre any quicker, but to do it different. And one of the opportunities for us is, many city centres or close to near to, they have large areas of water. There is an opportunity to change the sort of the number of segments of travel you have, not have to go out of town to an airport and then sort of back into town from the airport at the other end. So what you find is that actually, although we're significantly slower than a typical regional aircraft or even a 737, whatever, although we're slower, if we can operate from closer into the city, the overall time of journey from city centre to city centre isn't a lot worse via a hybrid aircraft or airship type solution. And I think the general public is beginning to wake up to the fact that overall journey time, yeah, that's okay, that's good. We'll be in the ballpark there. But if we can do it in both a greener manner, i.e. get rid of all that nasty carbon being generated, and also do it perhaps in a more comfortable manner, doing it in an environment that is not being crammed into a tube with your next door neighbour's elbow in your ribs sort of thing. We really feel that there's an opportunity in mobility, passenger operations that we can grow into. As I said, the freight side of things, it's a little bit more restricted with Airlander 10, but we're still seeing there are some particular routes that might prove sensible for us. Surveillance, another marketplace. There's no doubt the military still remain interested in it. Surveillance doesn't go away, and doing it in a cost-effective manner. We've been working with the NPS, the Marine Corps School over in California, for the last 6 months on a CRADA program, and it's really interesting to hear from the military about the fact they are being pushed towards greener solutions for their flying and their transport needs and so on. So I think there are still opportunities on that side of the fence. And the final piece, which is sort of where some of our early adopters are going to be sitting, is sort of the expeditionary tourism. But the idea of going somewhere without leaving a trail of carbon behind you, and yes, this is the more upmarket end of things. We're looking, an Airlander 10, we're probably looking at 20 passengers in sort of 10 double ensuite cabins and all the rest of it. That's sort of the picture on bottom right. But experiential tourism is a part of the potential mix. So what we've ended up with effectively is an aircraft that's much more flexible than the Lenvy aircraft. We're designing for a much wider marketplace. So where that takes us to is we've got to develop some technology, and really there's a couple of places we've got to go that will make us more efficient. We want to be early adopters of scalable zero carbon technology. There's huge opportunity here for us to help the aviation industry meet its sort of 2050 carbon targets and so forth. We have an opportunity with Airlander 10, although our first few Airlander 10s will almost certainly be kerosene powered, albeit almost certainly by then SAF. We're already on a path with hybrid electric power towards, by the time we're 8 or 10 Airlander 10s in, we'll be hybrid electric, so combustion engines and electric engines and fuel cells. And by about 2028, hopefully fully electric Airlander 10s. And the pathway then moves on into the other aspect of how we make these vehicles more efficient, which is let's take that fundamental of light and air. Bigger is better. Volumetric efficiency. The bigger we go, in actual fact, the cheaper these things per ton kilometre of freight and so forth, the cheaper they are to operate. Now, there are practical limits in there, obviously, and if you're trying to serve a remote community that only wants 10 tons of stuff delivered once a month, it's probably not, it's not going to be cost effective to rock up there once a month with 100 tons of freight on board. So there will be horses for courses in this, but our next steps beyond Airlander 10 are towards Airlander 50 tons of freight, that sort of order, 50 to 60, depending on the range. But we're already having conversations up in the 200 and 300 tons of freight range in due course. But at that sort of scale, what you're then moving into is you're sort of more competing with the shipping industry. You're starting to look at bulk freight from intercontinental ranges and so on. So there's a huge potential out there for our industry. The challenge is making sure that LTA is perceived to be a safe set of hands again. And there are really there's a couple of problems we have to get over. And I've spent most of my LTA life dealing with the first one, which is the preconceptions based on the distant past. I'd prefer to call them misconceptions, but there is no doubt, if I was in the shipping industry, I'd be deeply peeved if the first thing that everybody talked about was the Titanic. In our industry, there's another product out there that everybody leaps in on at the start and annoys the hell out of me even now. The other challenge for us all, I think, is we're bringing a disruptive technology to market in many respects. The world has got comfortable with aeroplanes and helicopters. The world of lighter than air, it is a disruptive technology. It means it can be challenging to get the public to accept it. It can be challenging to find finance and so on. So those are the big challenges currently going on. Hopefully over the coming month or two, we'll have some more news out of HAV that will show that we've got some of those not necessarily licked, but well under control. So the one thing that we've really found that's important over these last 3 or 4 years is collaboration. And the LTA world, if ever, it really needs to find ways to collaborate and make sure that we as an industry present a viable and a strong, whether it be safety or whether it be technology or whether it be operational, the operational side of things. It's important that we demonstrate to the rest of the world that we know what we're doing. So over the last few years, HAV's been working with both the LTA community, and on the next slide, I'll talk about some of the non-LTA community that we've been working with, both on design projects, operational and regulatory type projects and so forth. HAV and Flying Whales have spent significant time and effort on the development of SC gas with EASA, despite the fact that obviously the UK cut Europe off a couple of years ago and let them drift off the other side of the channel completely. But the SC gas regulations, they're very important to us, despite us not being quite so closely tied to EASA anymore. And between Flying Whales and ourselves, and then with review and oversight from EASA, we put together a sort of high-level set of safety codes. It's important that HAV, despite casting Europe adrift, it's so important for HAV still to be connected to the rest of the world in terms of regulation. It's no good for us just to certify a product under CAA in the UK. We need to certify products worldwide. So, our certification plan, although it will be headed up with the CAA, we'll be doing concurrent certification with the EASA and FAA as we move forward. We have had conversations with Transport Canada as well, and I think they'll play an integral part in our cert program as we move the product towards type certificate. But anyway, so a lot of work went on between ourselves and Flying Whales on that, great collaboration. Equally, while that was going on, a different bunch of us within Flying Whales, Zeppelin, WDL and ourselves have been working on development and refinement of some of the operating rules. There's no doubt that airship operating rules have lagged a little bit behind the rest of the world, but there's really starting to be a need now for us to understand and for us to know what the rules are going to be when we come to have to train pilots and maintainers and operators and so forth. And, what's the standard going to be for flight simulators? What are the crew flying hour limitations going to be? What pilot training are we going to do? What are the steps you go through to become an accredited airlander pilot, for instance? All of this is important, and it has a significant impact both on the operating cost. We want to be cost effective, but also it has an impact on the design of the aircraft. So between the 4 businesses I just mentioned, we've been putting quite a lot of effort into trying to make sure, with the EASA in particular, that the training regulations and simulator regs and so forth are sensible and sort of align with the rest of the aviation industry. And the other example that I should bring up is Flying Whales and ourselves. We've been collaborating on a sort of very highbrow sort of article for the ICAO Sustainable Aviation event in the autumn. And that piece sort of talks to the benefits of lighter than air generally, rather than how brilliant our products are. But again, we need to raise LTA up in the public's mind and in industry and government. So moving from that, we have also been doing obviously some technical collaboration stuff, predominantly with Collins Aerospace, University of Nottingham, under some grant funding from ATI. So we've been building a high efficiency electric motor and controller system. We're due to go out onto a ground propeller test rig in 2 or 3 months' time and actually run the motor, not just against a dyno, but against a proper propeller, and get some views on some of the operating rules we might want for that. Do you go for constant speed propulsion, or do you have you use variable RPM? There are lots of different strategies to be worked out, and they have an effect on the motor, and varying the speed of the motor can be challenging and so on. So this is very useful for us. It's one of those sort of core pieces of technology in our journey towards electric propulsion. But I guess it's not all about aircraft technology. I can't really have said that. We have also got a number of commercial partners that we've been working with over the last few years. So we've got AECOM, who are effectively building infrastructure, civil specialists. We've got a big project ahead of us to develop our production facility. We want to do that in an appropriately sustainable manner. It's a great opportunity. We're building from scratch, in effect, and we want to do it right. We want to make sure that we're putting back into the local community, whether that be solar energy from on top of it, making sure rainwater runoff is captured properly, making sure we have efficient insulation systems, and all of the normal stuff that one should strive for these days in a green facility. So we're working with AECOM on baselining that. And then the other piece I touched on 5 minutes or so ago is about our partnership with 2Excel with regard to training of flight crews and technicians, and the task ahead for that. We're looking at each of our airlanders. We're looking at them probably flying 3,000 to 4,000 hours a year. You're almost certainly going to have a couple of pilots on the flight deck. And for some reason, pilots seem to be so heavily protected, they're not allowed to do more than about 900 or 1,000 hours in charge a year each. So every airlander we build is going to require, 7 or 8 pilots to fly it over the course of that year. Our production plans are for many tens of aircraft. All of a sudden, we're looking at having to train hundreds of pilots. That's not an inconsequential thing, and hence our interest in the Airship Working Group with WDL and Zeppelin and Flying Whales and so on. We want to make sure we get the rules right with that, and 2Excel is one of our partners that is going to help us with that strategy for training pilots and getting crew qualified. The final group that we're tied into at the moment is the Advanced Manufacturing and Research Centre, spun out of Sheffield University a few years ago. They've got all sorts of amazing techie type stuff, both airborne, but more importantly, they're predominantly about how do you manufacture stuff? How do you do it efficiently? How do you maintain stuff efficiently? You know, the days of having a paper job card and 3 pages torn out of the manual and sending a technician up onto the top of an airship, they're long gone. We need to be efficient with the way we maintain these aircraft. We need to be safe as well. We need to take any guesswork out of how you do a maintenance task. You know, our goal with Airlander is we don't sell people hangars, we sell Airlanders. They go outside, they'll be on a mast or they'll be flying, and they stay outside the whole year round. So our goal is that all maintenance can be done outdoors, and that's required us to sort of challenge ourselves on how best to really do maintenance. You know, finding somebody from the design office who's prepared to go up on an ascender system 100 foot in the air to look at a problem a technician can't describe, it doesn't work. You need to be looking at whether it's hollow glasses or you know, 3D imagery and so forth. We want to make the whole of this a more efficient system. So the Airlander project has turned out to be much bigger than just building a few hybrid aircraft and gaining a type cert and doing a bit of technical stuff and having fun along the way. It's been very much about the end-to-end system, everything from training pilots to having facilities to supporting operators and making sure that the product will do what they want it to do. So we sort of see ourselves in a place where we've been a development business for many, many years. And now what we see ourselves as a production business. We've had the luxury, shall I call it? It's a horrible way of talking about COVID, which has been a terrible, terrible thing. But as an engineering team, we've managed to work through that. We've had the luxury of 2 extra years to make sure that the product we're bringing out answers the challenges that are out there. And it's going to be an exciting journey ahead. We're trying to deliver operational cost reductions to the transport industry. We're trying to support the initiatives like net zero and zero climate impact and so forth. There's a big challenge ahead, but we're sort of up with it. So just to wrap up, I'd like to say it'll be good to see a few more of you face to face at the conference later in the year. And I think at that conference, we'll probably focus a little bit more on the technology piece. What does an Airlander 10 actually do? How does it work for underserved places, the Canadian High North, for example, congested places? How might we work within containerized logistics? We'll talk a bit about our Airlander 50 and how that works as a container aircraft. But fundamentally, we sort of see the future of aerospace. It isn't a one-size-fits-all solution. And our goal is just to be able to deliver societal good whilst reducing the impact on the planet. And, you know, that's what we're all about. So thank you for your time.
Thanks very much, Mike. That was a great presentation. We've got a few questions in the Q&A here. We got about 5 minutes or so, I think, till we need to move to the next speaker. So perhaps we could go through a couple of them if that would work for you. Yeah. It looks like perhaps there's the first question I see that's come in, or one of the first ones came in, was a question about the risk of wind when landing. I would imagine that you guys have some plans for that.
So takeoff and landing is something we've been spending a lot of time working on. From the prototype aircraft, obviously we had a few bumps along the way with that test aircraft. But at the end of the day, we learned so much about the behavior of that aircraft. It took us back into the wind tunnel, for instance, to modify the hull shape a little bit, to make it a little less pitch sensitive and so forth. We've learned huge amounts operating that prototype aircraft. And the takeoff and landing stuff, yes, we were lucky that, you know, before we lost that aircraft, we had matched our flight simulator. So our flight simulator has been like gold dust to us for the last 3 years, and we've done a lot of work on takeoff and landing technique and so forth, and making sure that we can operate in, you know, winds up to 30, 35 knots for takeoff and landing. So it's part of recognizing that a product that can only take off and land in 10 knots of wind isn't going to be much use to the commercial industry. You know, we've got to be better than that. We've got to be competitive with airplanes or helicopters.
Perfect. I guess there's another one here talking about just the Canadian conditions out of curiosity, the nature of the shape and the performance during the winter. Is there a risk of snow collecting on the top surface, or is there mitigation for that if it does?
So we obviously have to watch out for snow. We've done a lot of study work over the years on snow accretion. One of the challenges with snow tends to be what type of snow is it, and is it wet snow or is it dry snow and so forth. But we've obviously had to look at our aircraft from the standpoint of it may well be operating in regions where there is snow on a regular basis. And we've got some systems built into the aircraft and some maintenance systems that we use on the aircraft to make sure that we can mitigate that snow challenge.
Perfect. And I guess I think we got maybe time for one more question. Just the notion of you were talking about pilot training and things. What's the requirement likely to be for that, and about when might you start looking at doing the pilot training at the beginning of that?
So the regulatory side of pilot training is something that probably we're going to be arguing with the EASA and CAA and FAA and so forth. We'll probably be arguing with them for the next 2 years, knowing the way these things tend to grind along. But obviously for Airlander, we're looking at being flying in about 3 years on our flight test program. And we know we need in the order of 8 pilots to be able to execute that flight test program. So we've got to have a robust pilot training process of our own. So we've been working through the how many hours do you give them in a conventional airship, followed by how many hours on a simulator, followed by how many hours in an Airlander in the sort of P2 seat. So we're working that stuff. I'm very lucky to have Dave Burns as my chief test pilot still. He's got a huge sort of background knowledge in the LTA side of things, but also he does understand, you know, civil aerospace pilot training as well. So a lot him along with others in the team here, we're just trying to make sure we've got a safe and practical process lined up, both to get ourselves flying for our test program, but then some of those pilots will almost certainly go off and become training pilots or instructors and so forth for our early customers. You know, it's important to us that we support our early customers to make sure they don't commit sins.
Yeah, absolutely, for sure. Well, again, thank you so much for your time today, and I really very much appreciated the presentation. We're going to move on, I think, next to our third speaker. So again, thank you so much, Mike. And we've got next up Gennady Verba from Atlas LTA Advanced Technology. Gennady has a deep understanding of airships and over 30 years of experience designing, developing, and operating airships and aerostats. He started his later-than-air career in the 1980s in Ukraine as a student of Lviv Polytechnic University, and since that time, he's led several airship and aerostat developments in the US, Russia, and China. Since 2010, his major efforts have been aimed at the Atlant, a new type of cargo aerial vehicle. And his presentation today will discuss the developments of the Atlas Atlant project, potential uses and impact of the technology. Gennady, the floor is yours.
Yes, thanks. Thank you. Let me switch to the... Okay. So basically, it was quite a long time. It was over 20 years. Since we visited the first conference organized by Barry Prentice, and we would like to thank you, Barry, for your devotion to the great idea of bringing lighter-than-air to Canada. And I think 20 years is quite a long time, and it's time to remind about ourselves and what we are doing and how we are doing that. Okay, probably let's work with this one. Okay, so let me introduce the company and our activities. So as you said, we had some kind of experience in lighter-than-air. During the last 30 years, we built 12 manned airships, and a lot of tethered systems. And right now we are working on development of sightseeing airships and also high altitude platforms. We are located in Israel. We have 2 locations, one of them in the central Israel, near this town of Rosh Ain, not far from Tel Aviv. Another one, specific facilities devoted to tethered aerostats in the south of central Israel. So there are several directions of lighter than air activities in Atlas LTA. The first one and more the most important for us is high altitude platforms. We used to work for Alphabet Loon for over 40 years, and we created a new concept, new hybrid concept of variable buoyancy motorized balloons. We wouldn't say airships, but motorized balloons. You can see the launch of this balloon. Working on this project, we created the new types of materials, new types of helium and hydrogen holding films, super strong and super light, capable to work in very harsh condition of very high UV radiation and low temperatures. And by the way, you see the picture of low temperature ground test. We have done this test in Canada, near Yellowknife at winter. It was almost like -40, very challenging, but very good memories about this test. Okay, so beside that, we design and produce different components for lighter than the air vehicles, like blowers, valves, and gas bags for rigid airships. And we think that our experience with high altitude is very useful for that, because we can use this same or similar extremely light and helium proof films and textiles for gas bags. Also, we produce various types of tethered aerostats, which is used for defense and sometimes for tourism, like our Skylift. Right now, Skylift is going to be certified in Israel and installed for the first time in the center of Jerusalem. Beside that, the tethered systems are extremely effective for persistent surveillance and communication purposes. But the main project for us is Atlant, which is heavy cargo aerial vehicle. For the beginning, we have 2 models, 16 tons and 60 tons, 60. And in the nearest future, we will start developing the 165 tons vehicle. We designed them for mostly for 2 markets, for 2 cargo niches of cargo market. First one is remote areas delivery, cargo delivery. As you know, this market is very demanded in Canada, and not only in Canada, in different climate conditions, this kind of activities can be extremely important. Another type is oversize, overmass cargoes delivery. The great example is a windmills blades, which is extremely difficult to transport using trucks or any other ground systems. Those are niche markets. Both of those markets are niche, but this niche is quite big. If you see at the size of the market, it is estimated by international expert community. It's over 20 billions. And many people are asking why by now any airship projects didn't succeeded practically. And in the past we had the beautiful airships and very natural questions why those creatures didn't succeed in the past. And we have a practical experience with conventional airships, and our answers is mostly the problem is with ground infrastructure, like big hangars, ground crews, and also the operational difficulties, like needs for ballast. In the past, it was use of hydrogen and some other very important issues. We have to learn from that, and we created the newer concept, which is basically designed to perform point-to-point delivery of heavy cargo and delivery to unprepared site. In the future, when the regulations will be developed, when we can perform unmanned flights. We are aiming on low operational cost, on very large size of cargo, and of course, which is very important now, is it should be very sustainable, very low CO2 emission. Also, very important characteristics should be ability to operate in a harsh weather conditions. As you said, we are aimed on operation with physical landing on ground and surviving not only in flight but also after landing, because it's also very challenging at the north and at harsh weather condition like snow, very cold weather, and very windy condition. Another challenge is very large cargos. Although we have very large cargo bay, we also consider carrying cargo outside the cargo bay. So here is additional ways of usage of our Atlant, like emergency response, which is very important. Of course, luxury travel and passenger travel. Very important is northern exploration, capability to carry cargo on trusses, of course, with limited weather condition, and also firefighters operation. It is important to say that our design is very suitable for quite large passengers, space for the passengers inside the Atlant. It's about 460 square meters for the smallest Atlant, which is Atlant 30. We can accommodate passengers and create some kind of public areas on board, and capability to land anywhere make this configuration very effective for experiential travel. So the key technologies, just briefly mentioned the key technologies of Atlant, is a rigid body. A rigid body is very important to survive at different weather conditions. Buoyancy control, we need to be able to ballast the gap between the dynamic buoyancy. Again, the Atlant is a hybrid aircraft, but it's still the difference between the dynamic buoyancy and full cargo capability of this vehicle. So after reload, we need to compensate it using pressurized air as ballast. Also, we need to have a VTOL capability. We need to be able to land on any flat surface using adaptive mooring. We'll talk about that later. And also, of course, compromised shape, which is typical for hybrids airship. Let me launch a small video with the sound explaining most of that.
Atlant can operate in most all conditions from -50 degrees Celsius and up to 70 in rain, snow, or any other weather. Atlant can land on a flat surface. When landing on the ground, deploys its self-mooring system to anchor the aircraft in one place. It requires no infrastructure and destination. The Atlant 100 can carry up to 60 metric tons. The much larger Atlant 300 can up to 150 tons. The cargo bay is enormous. It is up to 36 by 11 by 7 meters in dimension, totaling 2,400 cubic meters. If we look at other large cargo aircraft by comparison, you'll see that they are all dwarfed by the Atlant 100. Sized cargo such as turbine blades can be externally mounted. We've seen Atlant's ground anchors, but Atlant can also operate from water, even in waves up to 2 meters high. The Atlant's water mooring system works by lowering an empty tube into the water, which fills with water, thereby creating a sea anchor that keeps the aircraft stable. Atlant's many features make it the most effective aerial rescue vehicle. Deployed to a disaster area very quickly, carrying vital equipment and goods to the area of the disaster, and be used as up to 5 people in Atlant 100 to evacuate them from a disaster area, as well as carrying freight at the same time, and a field hospital built into the aircraft with operating facilities, perhaps an MRI, and spaces for up to 24 intensive care patients. One advantage for using the Atlant for such medical facilities is the lack of noise and vibration in flight. A number of different types of modules can be combined depending on the mission needs. The main purpose behind the Atlant design is to deliver cargo to is the delivery of fuel to remote areas. The Atlant has onboard winches and can be loaded up to or around. The Atlant is VTOL capable. For this type of VTOL operation, 3 to 4 times is needed for a short period. Besides the main power sources, which are diesel generator sets, fuel cells, for VTOL operations we use capacity battery packs designed for very rapid discharge. As you can see during the vertical phase of flight, power is being put into the power distribution system from the hydrogen fuel cells, from the batteries, and from the diesel generator sets all at the same time. However, when we transition to horizontal flight, diesel generator sets and the hydrogen fuel cells into the power distribution system, and it's used by the main drive pulses, but it also is used to charge the batteries. To ensure that the airship remains in balance during horizontal flight, we use both hydrogen to power the hydrogen fuel cells and diesel or jet fuel to power diesel generator sets. We call it the dual fuel ballasting system, the DFBS. By using this combination of fuels, we keep the airship in balance because as we use hydrogen in the hydrogen fuel cells, the amount of lift reduces. Concurrently, the weight of the aircraft reducing as we burn jet fuel or diesel. The footprint for each ton kilometer is reduced by up to 70% compared to traditional cargo airplanes, and up to 4 times less carbon footprint compared to the most efficient helicopters in service today. Thank you.
Okay, so because this conference is mostly concentrated on sustainability of the airship, we prepared this kind of explanation. Maybe it's not so optimistic yet, but in the future it will be much better. This chart showing the fuel consumption per ton kilometer, which is much more reasonable than hourly consumption, for instance. So for Atlant 100, we consider the consumption per ton kilometer as 82 grams of fossil fuel. But in the future, we have a possibility of considerable reduction of that. If we look at a little bit more of boring science, this is the comparison between the classical airship, traditional fixed-wing aircrafts, and Atlants. As you see, the fixed-wing aircraft is shown by purple horizontal line. This is 60 tons airplane moving with the speed of about 800 to 850 kilometers per hour, and spending about 138 grams per ton kilometer. The traditional airship, classical airship with DFBS system is shown on the fat red line, and the green line is a hybrid airship, and in particular Atlant. As you see, we are losing about 25 to 10% depending on the speed before classical airship, but this is the price we are paying for being practically usable in harsh weather condition, usable without any ground infrastructure. But the sweet spot is above 115 kilometers per hour when we are losing just 10%, or even we can be more fuel effective at very high speed, which is 130 kilometers per hour and up. As you know, in Canada, with the strong winds, it is important to have much higher speed capability, not flying like 90 kilometers per hour, which is not practical in that condition. But the next step will be a fully electric or a hydrogen hybrid electric version, which will use hydrogen and fuel cells. And in our projection, we think we can achieve this result much faster than fixed-wing aviation. You see the comparison, 10 years, not 15 years. The weight impact is much less. I will explain it later why we have this advantage. And additional cost is also less than for for fixed-wing aircrafts. Very important step toward Atlant is building the conventional airship for sightseeing, which is much smaller, but with scalability of the technology leading to the Atlant. So it is based on time-proven design of AU-30 airship, which we produced back 15 years ago. We produced 5 of them and using different conditions, including the cold weather conditions. We decided to make quite a deep modification of this airship, changing the propulsion, using the electrical propulsion and hybrid electric system. Here is the appearance of this aircraft. We moved the propulsors far from the passenger gondola and also added the third propulsion unit, which is located on the back of the envelope, adding maneuverability. Also, some design features providing the unique comfort in first class cabin and also in economy class cabin. But the main difference is the electric propulsion, which is under development together with our partners, Israeli company called Albus. It is based on diesel generator, based on German diesel engine, red A03, and the battery pack. But in the future, the same airship can be a perfect base to test the hybrid electric system. The hybrid electric system will replace the diesel genset by fuel cells. But the most important thing is how we are going to store hydrogen. It sounds probably a little bit difficult from the point of view of from certification authorities. We are storing hydrogen inside the helium envelope in separate volumes, in separate envelopes. Again, those envelopes also based on our achievement in material development. As you see from the beginning of the flight, we have a minimal heaviness of 50 kilograms, but burning hydrogen, we increase the heaviness and bring it from 300 kilograms after 55%, after 100 minutes of flight, and then after 200 minutes of flight is 600 kilograms. For 11,000 cubic meters airship is completely acceptable heaviness, is less than 7% of heaviness, and it is 200 minutes is enough, is more than enough for any sightseeing flight. So this is the chart showing the requirements to fuel cells. The fuel cells with the power starting from 240 kilowatts for cruise flight and ending up with 330 kilowatts for the maximal speed mode. And the gap between them, if you see on the chart, will be covered by the batteries for the short time. So that's very important step toward Atlant, because the smaller Atlant 30, is basically the 4 times bigger from the propulsion point of view than Atlas 11 airship, and we just use 4 propulsion systems of Atlas 11 to build the first Atlanta. So basically that's all. Thank you very much, and I'm ready to answer the questions.
Well, thanks very much, Gennady. It looks like we're actually a little bit tight on time for questions. There are a few in the Q&A if you want to find your way in and see if you can maybe answer a couple of them for the people that have asked. But it looks like we're going to have to move to the next presentation just to stay on time. So
Okay.
again, thank you so much for your presentation. It was very interesting and a lot of really good information. One thing I did get as a message though is it looked like there was some people had a bit of difficulty hearing the audio for the video that you presented. If there's a possibility of allowing access for us to see that potentially, so maybe we can email to people who want to see that again and to be able to maybe load it on their computer.
Yes, and also this little movie will be uploaded to YouTube, and I will send the link to everyone.
Perfect. Yeah. If you have the link for that, that'd be fantastic. Excellent.
Great.
Right, Ross. Well, at this point, maybe we could, if Frank, if you were there, if we could move the conference forward a little bit.
Okay. Yeah. Then we are starting with the. Actually, the last segment of this conference on regulatory frameworks. First of all, I would like to thank Professor Barry Prentice for the possibility to moderate this session. Thank you very much. For the others that I did not see before, my name is Frank Newman. I'm director of the Institute for Infrastructure, Environment, and Innovation. And yeah, it sort of triggered me in the beginning to hear the sound from Mr. Mike Durham that more cooperation is necessary and collaborative approach. That's exactly the also the angle that the Institute for Infrastructure Environment takes on. We established a collaborative platform, ULTA, particularly tuned to exercises that are focused on upscaling. And it's not only that we want to develop collaborative projects, but also that we want to attract supplies in supply industries like developers of envelopes or a cheaper way of testing and burst test for gas packs, expertise centers who are only doing that. And then for better budgets, then of course, when it would be just individual developers, each time making a separate deal. So the purpose of this platform is to encourage collaborative products and to find funding for it. And yes, now, in fact, one of our other activities also, we're organizing a meeting very soon in Africa, and the applications for light and air technology, it will be on 1 June. But I will not want to say too much about that. I think because of the reasons of time. So I would like to give then the floor then to Thibaut Proux from Flying Whales. And yes, Thibaut has an extensive experience, more than 8 years with Flying Whales, has been starting as a design engineer and now particularly specializing on safety. And regulatory aspects. Yeah, so Thibaut, please take the floor. Welcome to this conference.
Okay, thank you, Frank. Can you all hear me well and see my screen?
We can see your screen very well. The sound is a little bit soft for me, but maybe that's because of my sound. Let me see. Yeah, I think it's my own reason. I think otherwise we can hear you very well.
Okay, great. Okay, so yeah, thank you for this introduction. Thank you, Barry, for organizing this event for, I don't know how many times you organized such conference. And fortunately, we have to do it online this time, and I can't wait to meet you all. Again, I've seen a lot of participants and a lot of well-known names, so hi to everyone that I knew. So yes, we're gonna focus on certification for airships today. So my name is Thibaut Proux. I'm working for Flying Whales since 2013. And yeah, my main focus was about this huge challenge for Flying Whales and for any airship manufacturers, which is about how do we have to make it certified? How can we make it certified, such huge machines? So I will just split my presentation in 2 parts. One will be on what does exist today in terms of certification for airships. What does it mean actually to certify such machine and what are the, let's say, the wide range of activities that has to be performed to certify this machine and make it fly again in terms of regulations. And then I will spend more time on European initiative that actually Mike already presented a little bit. I will go deeper on this, and I will show you that we have made a lot of progress on these regulatory frameworks, and that this should be and is actually beneficial for all the industry, airship industry. Yeah, so my main message actually is to show you what we have done so far and to show that this can be used and should be used abroad the European borders. So what is certification? Usually when we think about certification, we always think about the administrative burden associated with it, like it's just a lot of regulations we have to comply with. It's quite unclear what we have to comply with. We don't even understand why we have to comply with such requirements. Sometimes it makes no sense. It's too prescriptive on our design. It's limiting the innovations, all these kind of ideas. Well, you have to understand that certification is just the best and only way to make sure that you will be allowed to make this machine fly and operated and make it a commercial product. But why do we have to certify such machines and everything around? Well, it's because we just need to make sure that our products are safe. That's the basic principle. We don't want to kill anyone with this machine, with these products. We are making flying machines that can endanger people that are inside the machines itself, but also that are on the ground. So we have to make sure that our product is safe. And well, in our airship industry, we have some kind of background events with that. I put here the Hindenburg accident that everyone knows well about. And as you can see, there were a lot of, let's say, it was the first buzzing event at this time. This event went worldwide, and actually it didn't kill entirely the airship world, but it at least impact significantly this industry, because even today, I can speak for flying world, but I think it was the same for, it's the same for everyone here. When we are trying to attract investors, attract talents, people to join the company, or partners, technical partners, or even political people, they all have this idea of airships being unsafe. And because they have this idea of Hindenburg that was like more than 80 years ago. So just to say that this event that went quite viral at this time impact significantly the society that still today have this image that airships are unsafe. And so the level of constraints in terms of certification can be super high. And why so? Because actually certification is entirely linked with safety. The more the society is expecting to have a high level of safety, the more the certification will be constraining. So I put here the example that is actually extracting from the FAA website. Well, you can see that a small UAV, unmanned air vehicle, has a low level of constraints in terms of certification, because the society can accept a higher level of risk, because it's small, because you have no one inside, because when it crashes, the inertia at the impact is quite low. So we can accept to lose such machine, let's say at a, not every day, but on a quite frequent basis. When on the other side, a huge airplane transporting 200, 300 persons flying at 13,000 feet above the ground at 900 kilometers per hour. We don't want these airplanes to go down every day. We don't want them to kill everyone every day, to crash on cities and so on. So the level of safety expected by the society is quite high. And then the level of constraint in terms of certification is quite high too. So for airships, we have to go into the same direction. We have to find where we have to position ourselves in this scale. What is the proper level of safety we should put in place? We should ask for airships to comply with. And then what is the proper level of certification we have to comply with and make the demonstration? So that's, yeah, that was the first idea. Then when we want to go deeper into what is certification, certification is not just certifying a product. Okay, the type certificate is one thing, but actually you have a lot of other things that you have to make certified. I put here in my slide some different approvals that any companies that are developing, producing, operating, maintaining airships or airplanes has to comply with. So a lot of approval that they have to get. Actually, certification is for any type of entities that are part of building up this machine, making it fly, operating it, maintaining it. So you have to certify the product, you have to certify the company that is designing the product, the company that is producing the product, the company that is operating the product, even the company that is licensing the maintenance personnel. So you have to have a lot of approvals. Again, this can be seen as a huge administrative burden, but it's a useful one because this is the only way to make sure that we'll make no mistakes. And at the end of the day, we will develop and operate a safe product. You have, I think you all know that you have to work with several civil aviation authorities, regulators. So we have ICAO, International Civil Aviation Authorities organization that is an entity from the UN located in Montreal. But you also have in each country a civil aviation authority. So in Europe, we have EASA. In Canada, you have TCCA. USA have the FAA. And so you have to make the demonstrations to these authorities, so to make sure that you are developing a safe product. The basic problem that we all face in the airship world is, well, we don't have regulations for airships. Regulations has been built up and iterated for heavier than air vehicles. You have for airplanes, you have for rotorcraft, but you don't have, or you have really little regulations adapted to airships. So it is problematic when you are operating an airship. You can ask for the operators to Zeppelin, for instance. How do they train their airship pilots? What kind of licensing do they have? How do they maintain their airship? How do they license and train their maintenance crew? And we have some problematic for the certification itself, to certify the airship itself. What are the certification requirements my airship should demonstrate the compliance with? And so facing this issue in flying wheels, we have been working for many years on these aspects. So on these two main aspects, I will talk about first about the type certification of the airship itself. So as I told you, when you want to certify a product, well, you have to demonstrate compliance with set of certification requirements. Okay, that has been again built up by several decades of experience. Problem is, for airships, we don't have this experience, or we had in the past, and sometimes we lost it. As you can see on my screen, there were actually a lot of certification requirements that has been built in the recent decades, in the past decades. And if you look at it quite deeply, it's quite correlated with an airship that has been developed at the same time. So these codes are quite design prescriptive, quite oriented on these designs. And again, if you look at what is today certified on an airship, you don't have so much. You have the Zeppelin NG that is certified, actually is the only one certified in Europe and in USA, and few others airships like in certified in FAA on UK or in Brazil also. And as you can see, there are not so much airships certified. And the problem that we faced in flying wheels many years ago when we start building up this machine is what kind of regulations should we take to certify the machine? At this time, my head of design organization and CTO asked me, okay, Thibault, what are the set of requirements I have to comply with? And I look at the existing code and I say, okay, CF30T or TAR, transport airship requirements, that was built for the cargo lifter project more than 20 years ago, is what is making the most of sense for us. So I pushed the code to him and to his team. And a few months later, he came back to me saying, yeah, well, this is so complex to comply with. This is not adapted to what we want to do. It's too design prescriptive. It doesn't capture the design specificities and operational specificities of our airship. And we don't really understand where the history of this or these requirements. And when I look deep into this code, what was bothering me a lot is the safety objective that was supposed to be covered by this code was not really the one that we identified. So we were missing the real target of what is a certification code, which is to cover safety objectives. So we had this issue. Okay, CF30T was partially applicable. I put you the schematic of our analysis at this time. So most of, let's say 50% of it was applicable, but 50% was not understandable, was to be deeply investigated and to be modified or to be questioned. So it was quite complex to comply with this code. And then we came up with this idea, discussing with EASA and with other projects, that we could have another approach to have some kind of high-level code that is safety-oriented, that is operation-based, that is just defining just what are the basic safety objectives that we want to cover with certification for this type of airships. And yes, this is what we came up at this time. And then we had this important discussion with EASA and with hybrid air vehicles, Zeppelin, WDL. And as Mike presented earlier in I think it was 2018, November 2018, where we came out with this issue. And we together decided to build up this group named Airship Manufacturers and Operators, where we built up two task forces. One was especially on the certification codes, to have an harmonized code with Zeppelin, with hybrid air vehicles, with flying wheels, which we all have quite different type of airships, okay? Passengers, cargo, hybrid, pure equilibrium, rigid, blimp, or semi-rigid. There is a lot of different type of operations and design features, and we wanted to have an harmonized code. So it's quite difficult approach to converge the certification codes. And then the second task force that was really to focus on the rules for operations. So about the air operations, the flight time limitations, the flight crew licensing, and so on. So since 2018, we've been working together in a partnership, in cooperations, to build up these regulations. And so on the certification code itself, I will not go into all the details, but let's say that we follow an approach that has been built up by EASA around 2017 on CS25 Amendment 5, which is for general aviation, and on the VTOL, the vertical takeoff and landing types of vehicles. So we follow the same approach. We look into all the existing regulations for airships, and we try to cover what is the essence of safety for airships. And we push the code with hybrid air vehicles. We push the code to EASA around end of 2020. It was a long process since 2018 to reach this harmonized code with hybrid air vehicles. And then we push it to EASA, that went to an internal process and then went to public consultation. And then finally that iterated the code up to a final publication beginning of this year. So as you can see, it was many years of activities with hybrid air vehicles and EASA to come up to this special condition for gas airships, which is quite basic. It's like 30 pages, one of the requirements. And when you look at it, you're like, yeah, well, okay, that's obvious. We have to, okay, if you want to fly your airship in lightning conditions, you have to protect against lightning. It makes good sense, a lot of sense. Nonetheless, it defines a proper safety objective for airships. And this is the first time that EASA is publishing officially a certification code for airships. Just one point here also, just to let you know the amount of effort that we have to put in place, we had to put in place for reaching this certification code. My team is composed of 4 people. We have spent, I think, maybe 50% of our time building up the SCGAS for the last 3 years. And I didn't count in here all the designers and CVs that work with us to converge on this code. So it's a consistent effort for flying wheels, just for 30 pages code, but that is actually making our life way easier. So I will just go a little bit deeper in the SCGAS that has been published by EASA. So it's a code that is allowing you to design an airship and certify an airship that is using all type of lifting gas. So you can use hydrogen, helium, or hydrogen, okay? And you don't have a strict requirement saying usage of hydrogen as a lifting gas is banned. This is not what you can find in SCGAS. You will find something different that will allow you to use hydrogen, but you have obviously to make the demonstration that it's a safe usage, okay? I don't spoke about hot air airships because there is already a certification spec for that. But it's also a code that is allowing you to develop and certify any kind of airship structure. So if you want to do a purely rigid, like flying wheels, a semi-rigid, like a Zeppelin NT, a pressured airship, a metal clad, whatever you want in terms of structure, you can use the SCGAS. Same goes for the lift capacity. Are you using a pure equilibrium airship or a hybrid type of airship, well, you will see some requirements that are specific to each type of airship lift. It also covers almost all type of propulsion systems. For instance, in flying wheels, we have a quite specific hybrid electrical propulsion system. I quite doubt that we can use only AC gas to integrate fuel cells yet. It's something that we had in mind for a long time. I think we'll have to, it's quite innovative, so we'll have maybe to use other type of certification spec or special conditions that are ongoing on EASA world if you want to integrate such technology. And it's also a code that is allowing you to do all type of operations, passengers, cargo, surveillance, tourism, whatever you want. The code is not prescriptive for that, so you can use it also. So as I told you, if you want to do some specific things that we didn't include it in the SCGAS, like unmanned airships, high altitude, or specific propulsion systems, SCGAS is a good basis, but you will have to club other type of requirements to make sure you cover these specific aspects. Then on the other side, the second working group that we have been deeply involved in with HAV and Zeppelin is about what EASA calls the best intervention strategy. It's an internal formal process of EASA, where again, since many years now, we have built up a proposal to EASA on a set of rules for airships operations. So what is about the flight time limitation? Because when you want to fly an airship that is supposed to fly for many days, for several days in a row, well, the flight time limitations for the crew is critical. And it's a critical topic that you have to tackle and that you have to find solutions on. Because if you just stick to what is existing, well, you cannot make it that simple. The air operator certificates also is a tricky thing that we have looked into. The flight crew licensing, again, you don't have commercial pilot licensing for airships, for instance. So how do you want, how can you certify flight crews to operate your airships? And as I think, I don't know who said earlier today that they will have to to license maybe hundreds of pilots. The same for us. I think Arno showed you earlier that we are targeting a market of 150 airships worldwide in the next 10 years. So it's a lot of pilots that we have to train and to license. The continuing airworthiness also, it's a huge topic that we have to tackle. So on one side, the SCGAS is already published, and the next steps on the SCGAS are to work on the means of compliance. Maybe it will be published one day. Here, we are in the middle of the process with these airship rules. A first consultation already occurred last year with EASA. We are in the second consultation phase now. And while the next steps are to integrate the proposals that we reach with HAV and Zeppelin into what EASA call rulemaking tasks, specific tasks actually, that will investigate the proposals and that at the end of the day will build up the new regulations. Then we'll have to go for notice for proposed amendments and one day opinion for to the EU Commission. So here we are in a multi-year process, and that's why we started super early for our project, because even if we are not operating the airship in 2 years from now, but maybe in 4 or 5 years, well, we have to tackle it today. And as you can see, it's again a huge effort, we put a lot of resources on this aspect to make sure that we'll have the proper rules ready on time. Yeah, so just one more details on the airship best intervention strategy. Again, 4 main focus, one on the air operation rules for the personnel, the air operator certificates and so on. The flight time limitation, when you want to fly many hours or many days in a row, the continuing airworthiness licensing, and the flight crew licensing that has been even discussed at ICAO level. Because again, all these rules are non-existing today for airships. If you want to adapt what is existing, is already quite a huge challenge, but we have no choice. No choice. We have to adapt what is existing. Sometimes we have to build up new regulations, and it's a really long process. That's why we anticipated many years ago. So as a conclusion, well, again, we spend significant time on European side with HAV and Zeppelin and WDL to build up the regulatory frameworks in terms of type certification, in terms of air operations, to make sure that we'll be able to certify these machines, to certify the operations. And at the end of the day, that are paving the road to the next generation of airships, next programs, but also the next generations of airships. So we have done it on our side. We spend a lot of time with that, on that, a lot of effort. We are progressing quite well. We have some good achievements already with the SCGAS publication, with the BIS first steps that went quite well also. We are still in the process of continuing this progress. My point is, we again spend a lot of time on this, and this can be beneficial for everyone. It should be, actually. It can be useful for a lot of other type of airships products, for a lot of other type of operations. And at the end of the day, this is, in my opinion, what is the best way to ensure that this industry will develop itself. So again, these initiatives can and should be extended out of European borders. It will ease the mutual recognition and validations of our type certificates, of our operations, and so on. And again, it's beneficial for everyone. So I hope that we will be able to talk about it more in details in a few months when we meet together, all together in Canada. I can't wait for that, frankly. I would love to meet you again. Yes, and that's it for me. I hope that you enjoy this presentation. If you have any more questions, please let me know. Don't hesitate to contact me also if you have more questions on the certification and regulatory frameworks that we have been working on. We are still in Flying Whales on the path of getting the type certificate. Target date today is 2025, 2026. We are working with EASA and Transport Canada. So it's a long process, but we are on the good path for that. And yeah, I hope you enjoy my presentation, and give you the mic, Barry and Frank. Thank you.
Yeah. Thank you very much, Thibaut. It was an excellent presentation, a very good overview, also a good description of the part of the process, of course, the type certificate process. A couple of questions, actually. I think the first you may have already been answering. That was if Transport Canada was involved during the process. That seems to be the case. And then there are two other questions, particularly focusing on the EASA, or one question, actually nearly two, on the EASA trajectory from Johannes Eising. What are the consequences of abandoning the balloon mode? And that's a little bit a point I know in this this SC gasback discussion, the near equilibrium requirement. Do you see this question? It's,
no, I don't see the question, but I get the point. So first of all, about the Canadian aspect. So I think Arnaud showed you a little bit earlier, but at the beginning of the program, Canada was not part of the program at the beginning, very beginning. So we targeted the EASA certification only. Then since 2019, Canadian and actually Quebec government under the shareholding structure. So, and this is when we discovered that there are a lot of interesting markets for flying whales in Canada also. So we decided to investigate deeply the what we call concurrent certification. And actually, it's quite recent. I think we have some TCC representative here that I talked with like few weeks ago at EASA. So yeah, Flying Whales is targeting a concurrent certification with Transport Canada and EASA. We are just starting the process, so we are just starting it. Then about the question from Johannes about the free ballooning mode. Actually, it's not. It's part of the SCGAS. I noted this comment. I don't know where Johannes asked me about it already, but actually it's part of the certification code of the SCGAS. It's a high-level code, so it's quite interpretative, and that's obviously the objective. But as I can tell you, Flying Whales LCS 60T is targeting a free ballooning mode that is categorized as hazardous, not catastrophic. So it's something that we have in mind, and SCGAS is allowing the free ballooning mode. EASA is quite open on this idea also. So yeah, I can send you the exact requirements that is pointing on the free ballooning mode if you want.
Yeah, and then Sven asked about the airworthiness certification. Of course, that's a step further, but that's something which you have not worked on to great intensity, I think, so far, right? Because yeah, you first need to have the carrier, of course.
I didn't get your question.
Well, after the type certificate, of course, if you want to fly, you later need the airworthiness certificate. And I think there's one. Yeah, Sven is asking about that.
Yeah. So certificate of airworthiness is something that will come later on. again, on our process today, we are still not at the beginning because it's been like more than 8 years that I've been joining the company. But no, what we call the COFA is Certificate of Airworthiness, is something that we'll launch at the end of the certification.
Yeah, and then there are some questions being asked about the lengthy process, which is of course quite common for this kind of complicated certifications, and how you fund it. But I guess, yeah, it's just pain which you have to go through, right? Because you want to put something in the air, yes, you're obliged to take these steps. So there's not much to do about that, actually.
Yeah, so certification is obviously a huge constraint when you are developing a new flying machine, but you have no choice again. When you are talking about what is the effort that a company should put on certification, some will say that it's between, let's say, 30 to 50% of your engineering time. That is huge, obviously, on the overall cost of a program. Well, what I can tell you is our certification team is composed of more than, well, today it's five people full time. So yes, it's a huge cost. It's engineers, so it's quite expensive too. But yeah, that's the way you make it certified at the end of the day. So no real choice here.
And then there was another question, and the last question, and this was about the unmanned airship, how that is discussed. But I think you answered that already in your presentation by saying that part of it could be also applied to unmanned. And the question was actually whether they're considered as drones by the EASA. I think that is the case, actually, because there's this special drone regulation. The drone regulation doesn't say if it's a light in the air or not. It doesn't give any description for that.
Yeah, but, so yeah. This specific type of aircraft, actually, it's a combination of what is existing. So that's why I told for the unmanned parts, you can use specific special conditions that has been built, and you can club together the specificities of SCGAS with these codes. Same goes for the fuel cells or this kind of innovation. You can club together to have a good certification code at the end of the day.
Yes. Okay, and I think then we dealt with most of the question. There's one rolling in still that is already being discussed, the unmanned one. Yeah. Yeah, of course, as chair, I'm not student to ask questions, but very curious. So to what extent, very short question, to what extent you already also was are looking at the air services regulation? So because you are also plan to use your airship in Europe, what about the air service regulation? Did you already think of that, or that's maybe already still a little bit too early because it's about the pricing of your services in the end? Yeah.
I didn't get your point. I didn't get your question, actually.
Yeah, the air services regulation within the European Union arranged then how pricing is arranged for services to transport goods over the air, by the air. And yeah, that is not about safety, but it's more about price setting and how you make customers pay for your services. Did you already look into that or not yet?
Yeah. So again, today Flying Wells is developing an airship product, and we'll make it certified. So we are already starting to produce it. Tomorrow, Flying Wells will be also an operator. So we are building up a company named Flying Wells Services that will operate the airship and sell flight hours to customers. So obviously, costs and all costs in terms of operations are taken into consideration in the design of the machine itself. So I will not spend all the details, obviously, but it's something that we have in mind since the very beginning. And in terms of regulations, it's also something that has an impact. When you want to operate your machine out of Europe, even in Europe, you have to take a lot of regulations that we are dealing with. You know, when you want to operate it out of Europe, if you want to cross borders, if you want to transport goods from one country to another, it's quite complex. If you want to transport dangerous goods, it's also another regulation. So this is something that we have in mind, that we are investigating and that we are tackling when we identify some potential gaps that we have to work on.
Thank you very much.
Thank
you very much. And of course, some of the questions can be also asked later in the chat. Thank you very much, Thibaut, an excellent presentation. Then I would like to give the word to the next speaker. I hope I pronounce this rightly, Mr. Sylvain Bouquin from Transport Canada, who is not only an expert on regulation, but also actually a commercial pilot himself, as well as a drone pilot. So yeah, it couldn't be better fit for this seminar, of course. I will not talk longer, so I would like to invite you to the floor, Sylvain. Yeah.
So the presentation I prepared is mainly about the regulation actually in place in Canada about the remotely piloted aircraft. It's not specific to airship, but for now, so I will go in much detail, but for now the regulation it's more covering the below or the up to 25 kg remotely piloted aircrafts. And above 25 kg, it's possible, or kilogram, it's possible, but under SFOC airpass. So this is like a summary of my presentation. So my name is Sylvain Bourque. I'm a civil aviation inspector, and I will be later. I will be presenting. I will be helped by Carlos Riella, who will help me to answer any question, because I'm a pilot, so I don't have the engineering background. So since he's an engineering, hi Carlos, thank you. Okay, so I'm working for the AirPass Task Force within the flight operation team, and Carlos is within the engineering team of the AirPass Task Force as well. So I'm an advanced pilot with a flight reviewer rating, also commercial pilot, and also a glider instructor. Before being with TC, I was a national drone chief pilot for CBC Radio Canada, and I've made a lot of operations. So I have a lot of operation on small RPAs. So for this presentation, we'll cover CARS Part 9 regulation that it's actually enforced for micro RPA, for small RPA, which is 250 grams up to 25 kilograms. And also I'm going to share what we are actually working on. It's the low risk BVLOS operation up to 150 kilograms. And after that, we'll have a we have a question period. So part 9 of the CARS Part 9 is in force since June 2019. And in Part 9, a drone, or in CARS, drone is named a remotely piloted aircraft. So our RPA is so this is CAR definition. So it's a navigable aircraft other than a balloon of a rocket or a kite that is operated by a pilot who is not on board. So when you fly a drone, even if it's a small drone, you're a pilot of an aircraft and regulation applies. So the RPA plus the control station is called the remotely piloted aircraft system, or AirPass. So there are as a summary, there's 3 RPA weight categories covered under CARS Part 9. So one, the below 250 grams, which is called, we call it the micro RPA. Small RPA is 250 grams up to 25 kilograms. And there's 2 operation category, the basic and advanced operation. And I would say 3, which is the above 25 kg, that is not, there's no specific regulation on this weight category, but you can operate them under a SFOC, which is a Special Flight Operations Certificate. So CARS doesn't apply to RPA operated indoors or underground. So, and like I said, we're working on a regulatory development process for low-risk BVLOS and VLOS and BVLOS up to 150 kg. So quickly, so for small RPA, which is 250 grams up to 25 kilograms, there's basic operation, which mainly is when you're flying your RPA more than 100 feet or 30 meters from other people, or flying in uncontrolled airspace, and also more than 3 nautical miles from airports, and more than 1 nautical mile from heliports. So in Canada, aerodromes, which is more of the where is most of the aerodromes. So these are not so the basic operation, you can fly close to aerodromes, but not from airports, which are aerodromes holding a certification. So for advanced operation, it's when you can fly less than 30 meters or 100 feet from people or over other people. It's when you can fly in controlled airspace or less than 3 nautical miles from airports, less than 1 nautical mile from heliports. So we developed some tools to know. So for the small RPA pilots to know where they're flying, if it is controlled or uncontrolled airspace. There's the drone site selection tool, which is hosted by NRC, and also the nav drone viewer, which is a interactive map. So RP pilots can have a nav drone account, which is used to provide or to send control airspace request to fly in control airspace, and you receive your authorization. So most of the airspace, most of the control airspace authorization are given automatically when they're, let's say, away from airports and in low risk environment. So it's like instantly, you receive it instantly. Okay, can I fly above 400 feet? So it's a question we often often receive. Can I fly above 400 feet AGL over infrastructure? And the answer is yes, since in our regulation, it's permitted to fly legally 100 feet over a structure and 200 feet horizontally on each side. So this is possible, let's say over a CN tower, over a, let's say over a transmission tower, like a TV transmission tower, or even a power line. So that may give you some ideas in the future for the, let's say, BVLOS operation, that if they're 100 feet and below an infrastructure, they're respecting CAR Part 9. That's it. Okay, so keep in mind that other rules may apply. Because why I'm saying that, it's because we often receive some question about privacy. Hey, there's somebody using my drone to film inside my house. Can you do something about it? Yeah, it's not TC, so we're regulating the airspace, but not how people are using the aircraft. So same for, there may be also other federal, provincial, or municipal legislation that could apply. Like in Park Canada, there are some rules that limits the use of drone in national parks, and same in provincial and municipal, and some provincial and municipal parks. So also check the limit on wildlife, because like if there's a species act or marine mammal regulation, that also applies to RPAs since they are aircrafts. So that's it for the small RPA regulation. So as a summary, so all aircraft, including all RPAs, need to stay away from restricted airspace. NOTAM, if there's a NOTAM, a forest fire, so 5 nautical mile forest fire, away from an emergency situation. Small RPA needs to be registered, kept in VLOS, and up to 400 feet or below 400 feet for sure. So 250 grams and above, so even the above 225 kilogram drones or RPA need to be marked the pilot need to hold a RPA pilot certificate. So the aircraft needs to be more than 3 nautical miles from a so all RPA needs to stay more than 3 nautical miles from a military aerodromes, or away from special aviation events or advertised events. This could be permitted. These 3 could be permitted under a special flight operating certificate. So for basic operation, these pilots need to stay away from control airspace, more than 3 nautical miles from airports and military aerodromes, and more than 1 nautical mile from heliports. They need also to stay more than 100 feet away from other person. So there's also other regulation in place, but these are the, let's say, the key elements of the basic operation if we compare to advanced operation. So for advanced operation, the pilot needs to have an advanced pilot certificate. He can fly in all airspace. When I say all, it's not the restricted airspace, or not the one that I wrote in the first line. So they can fly in uncontrolled and controlled airspace with NAV Canada, NAV drone authorization. But they also need to have the right RPA, which stands for they need to comply, the RPA, the aircraft needs to comply with the standard 922, which is a standard for safety assurance declaration. If they want to fly in control airspace, so these are 3 different standards. One is for control airspace, near people, which is less than 100 feet, but up to 16 feet or 5 meters. Or the third one is over, if you want to fly over people, there's a third safety assurance declaration with a standard. If you want to fly less or over, less than 5 meters or 16 feet from people or over people. So now there's some numbers that it's interesting. So since the implementation of Part 9 in June 2019, so 63, we have more than 68,000 small RPAs that are registered. So this is, and the micro RPA, which is below 250 grams, this, like the Mavic Minis, they don't need to be registered. So the Mavic Minis are not part of these small RPAs that are registered. 68,000. So in 2020, there were over 33,000 traditional aircraft registered in Canada. So these are airplanes, helicopter, gliders, balloons. So there's a lot of small RPAs out there. So we're passing the RPAs, the RPA exam online. It's possible to pass the RPA exam online. So, and now up to now, so there was 143,000 exam, almost 70,000 basic pilot certificate were issued. More than 7,700 advanced pilot certificates were issued. There's 762 flight reviewers out there affiliated with school that are passing the flight reviews to the pilot or asking for a advanced pilot certificate. And there's 15 law enforcement agency who made a partnership with TC to enforce Part 9 or to give a ticket. So if you're above 25 kg or willing to fly near an advertised event or less than 3 nautical mile of a DND aerodrome, you need to ask for a SFOC pass. There's 9 reasons to ask for SFOC. You cannot ask for SFOC to bypass Part 9 regulation. It's only for a specific reason. So I will talk mainly about low risk BVLOS and above 25 kilogram operation, since I think it's more that kind of operation that airship people will look for. So basically, it's for uncontrolled airspace and isolated areas, and also for atypical airspace and also isolated area. So the definition of atypical airspace can be found in the AC 903001 as any of the following. So it's a restricted airspace. Atypical airspace, it's a restricted airspace with the permission, and northern domestic airspace outside of an airport environment or below 400 feet, or within 100 feet or less, and 200 feet laterally of a building or a structure, like I explained a few slides ago, in the uncontrolled airspace and outside of an airport environment. And like I said, airport environment, it's not outside of an airdrome environment, it's outside of airport environment. So it's all based, so everything is based on the AirPass operational risk assessment. This came from JARIS, which is a Joint Authority of Regulator. Sorry, I don't remember the rest of the name, but you know, it's this process is based on a JARIS model, and we adjusted to the Canadian situation. And so this is the foundation to allow BVLOS and above 25 kilogram SFOC. So but the guidance material is found in the Aviation Circular 903001, that it's available on our website. So we came out with standard scenario, with specific for the ORA, specific for above 25 kGA, BVLOS and above 400 feet AGL. They are available in a draft Appendix D of the AC 903001. Now this draft is available. It's not available on our website. It's a draft, but at the end of this presentation, you will have our email address and you can ask for it. So low risk BVLOS was published in 20. We're working on the next regulation, which is a low risk BVLOS regulation, and that covers up to. So it was published or announced in the CARAC in April 2020 as a notice of proposed amendment. Name is NPA 2020-012, and it's on AirPass low risk. So after this announcement, we received 230 stakeholder submission that that in the 60 days comment period. So, and now we're working on finalizing the regulatory package. So if you go in the CARAC NPA 2020-12, you will see on the right, you will see other documents that are listed on the right of my screen. If you want to know more about what's coming. So the regulatory package will be announced in Canadian Gazette Part 1 in the end of this fiscal year. So we're looking at the end of 2022, but we're not controlling the issuance date. And Part 2, usually it's 1 year after the CG1 is published. So amongst others, so the NPA is covering BVLOS operation level rating for the pilots. It's a rating on the advanced pilot certificate. It will also cover a medical requirement using a self-declaration. It looks like the actual class 4 medical certificate declaration, but needs to be endorsed by a physician. Actually, just to share that, for the small RTA pilots, they don't need to have a medical. There's no medical requirement, but there will be for the above 25 kg and BVLOS. So there will be also a ROC, an AirPass operator certificate, similar to the traditional AOC, and scaled down for low risk airpass BVLOS operation. There will also be an update on the standard 922 for manufacturer safety assurance declaration and declaration plus for, I would say, higher risk, higher weight RPAs. So also there will be information on our requirements for the DAA system, which is detect and avoid, which is the basic of BVLOS operation. If you don't have a DAA system, sorry, you cannot do BVLOS outside atypical airspace. So these two tables are on the left, it's the low risk BVLOS operation. On right, it's the VLOS operation. And now our scope is working on up to 150 kJ. So no worries. This is like for if you have an airplane license, you can take off with your license and it's exactly the same thing. So if you could fly up to 150 kilogram RPA with with your pilot certificate with the complex pilot rating, and if you're filling up the regulation or the requirements of the regulation, so you can do it without asking for a SFOC. If not, if let's say you're a 200 kilogram remotely piloted aircraft, no worries. You can still fly with a SFOC and with a risk assessment. So low risk BVLOS regulation is developed with international collaboration with other civil aviation authorities, including the ICAO RPAS panel. We have representation. We're part of the ICAO RPAS panel, and also we have a leadership at JARIS and a representation that are by one of our engineer folks. So we also have engagement with other aviation authority, which includes United States, Europe, and so I'm almost finished. So and to help to set up these requirements, also we're working closely with the ICAO, RTCA, ASTM, and JARIS. For more information, so you can look at our drone safety website. And that's so Carlos is there with me to answer any of the engineer specific questions. And thank you very much.
Thank you, Sylvain. That was an excellent presentation and a very good and detailed overview. I get the message from Barry that we have not much time. That's really a cutoff. So I would like to thank you, but let's see if there are some questions. Please ask the questions. I see one question here that was from Nathan Smith, a likeliness of drone delivery from an airship. We all know this picture from Amazon. I have some thoughts about that, but maybe there is somebody else from the developers who like to respond to this, or Sylvain, likeliness of a drone exiting an airship, maybe flying whales. Say something about that. Thibaut, do you have any thoughts about that? Did flying whales also look into this?
Yeah. So first,
Sylvain first, of course. Sorry.
I could answer on the operational side. So for all aircraft, including an RPA, if you want to deliver goods, something, you need to have a, sorry, I don't have the, so you need to have a, it's not a certificate, but a permission from the federal authority, which is, sorry, I don't remember the name, but not like if you're a commercial operator carrying goods, you need to have so you need to have a permission from that authority, and because there's also regulation. So let me find it, but so it's the same. It's not as easy as it looks when you look at the animation of Amazon.
Yeah.
But yeah, it's possible, and some Canadian company are working on delivering some, I would say, medical, some and some stuff that the concept was already proven, and I think it's possible. Carlos?
Yeah, thank
Yeah,
you
I was
very
going to
much.
say it's a commercial license that you need to deliver cargo with an RPA with any aircraft in Canada. So that would be one of the constraints, but technically speaking, I believe it would be feasible to land on an airship and take off from it.
Yeah, I think in the movies it was a little bit optimistic though on LinkedIn a long time ago. It looked like Battlestar Galactica, like there was no gravity, there was no mass issue. But I think Flying Whales also has developed ideas for a flying hospital. So maybe Thibaut, can you say something about this matter?
Yeah, can you hear me clearly? Yeah, can you hear me?
Yes, we can hear you. I cannot see you, but I can hear you, so it's okay. Go ahead.
Yeah, so your question was about RPS, right? Remotely piloted aircraft, right?
Yeah, but also there was one of the attendants who asked the feasibility of drone delivery from an airship. So like a larger airship and an in and out flying drones. There's of course a lot of challenges for the mass and how to compensate that. But
yeah, so it's not something that we are investigating currently in Flying Whales. We have many markets, but delivering goods in flight using a UAV is not something that we have thought about and that we want to target so far. We are really using our huge payload system, using several winches to load and unload. Yeah, even the hospital that you mentioned, that is a huge payload, quite large and heavy payload. We are just delivering it in hovering flight. We are not using any drones or UAVs.
Okay, thank you very much. Yes, and if I see no other urgent questions coming up in the question Q&A, so then I would like to stick to the time and give the word back to Barry. Yeah, so just a very small item, which I mentioned in my earlier introduction, this meeting we're organized together with DG Environment and DG Klima of the European Commission. I will put some details in the chat, but I will not talk much longer about that because of the time. And yes, thank you very much, Thibaut, and also Sylvain, for your excellent presentations, and also a lot of slides actually to look at for a second time. I heard the slides will be distributed. So yeah, thank you for these extremely interesting presentations. And then I would like to give the word back to Barry. Barry, thank you very much also for asking us to moderate this session.
Thank you very much, Frank. It's wonderful to have an experienced moderator, and thank you to the presentations. I think there's a lot of aspects about regulation that need to be encompassed in terms of the airships. Certainly one of the things that came to my mind was that limit of 400 feet. How fixed is that? Because the airships probably need to operate a bit higher in order to be safe, but I'm sure that's one of those hiccups or issues that will come up as time goes on. What I'd like to do very quickly, and I hope my success at sharing the screen is better than Alan's was. I'm not going to try to show them, but I presume you can see now. What I want to do is just show you a little bit about what he was going to offer to us. If this thing will advance, there we are. That, of course, is what his design looks like. But what's significant is that these are the works that he has in place. He's in the process of building his demonstrator. I had an opportunity to tour, so I know a bit about it. But you can see in this slide that there's a lot of his framework is already being built. It is a very unique situation where he has his hoops and his places is located in France, where it's being done. I'm going to go to this slide, which shows his compression system. This is a previous works he had, and he has his compression tanks all the way along the bottom of the ship. This is a picture that shows actually building the pressure tanks. And this is the end for the pressure tank, also designed and built. Here we have again, the design. These containers have doors. So there's doors within them. You can open these doors, and there's a turntable here. So his actual device works on a turntable. This is a 30-meter high crane that can lift the bits and pieces. And of course, there's a rail line, a rail track on either side. So it can move the full length of the operation to again a picture of what he's hoping to deliver in the end, and so on. And I feel very badly that we weren't able to have Alan give this presentation himself, because I know he'd do much more justice to it than I did, but I thought it was important at least to see some of the slides that he had. what he's where he's up to. Much farther along, perhaps, than people might think. For my part, also, I'd like to make a few concluding remarks, and also I have another screen I want to share with you just briefly, which is the presentation from one of our colleagues in India, who is organizing a very interesting conference in Mumbai. This is on June 22nd, 26th of this year. In fact, I actually have a small role in this, but it's also, I think, evidence of around the world work that's going on in airships. This is from the Institute of Technology of India, which is one of the leading universities in the world, in fact, in engineering. So again, interest, and we can see in this conference that we're having today, the worldwide interest in looking around. I said that yesterday we had 5 continents presenting or participating, and in fact, thank you to Daryl from Australia. We have our 6th continent that's involved in watching this webinar, so it really is a truly international event. I know that everybody won't be able to make it to the conference that is coming up in October. This is going to be the in-person conference. What we have done with the webinar is, in place of having the in-person conference we had planned to hold in Montreal, for various reasons, we postponed that to October 20th and 22nd, which will be in Toronto. But there will be more information available on the Isopolar website, as well as others and promotions that are coming. So to keep that in mind. So I'd like to make a few concluding remarks now. First of all, I think one of the things that we see from this is that the multiple uses and the quotes were used, horses for courses. And certainly it is true that, you know, there's different airships for different purposes. One airship isn't going to do everything and shouldn't be expected to. And there are some niche markets, as was pointed out, but these aren't small. These are very large niche markets. If you think about locating wind turbine blades around the world, as we're trying to get off oil as an energy source and move more to wind power, we're certainly going to need a lot more locations. And of course, the airships can bring in much larger blades, which is more productive and better for the system. So that's just one of the niches. There are many more that we could talk to, and certainly in this presentation, you've seen quite a few of those. The other theme I think came through is this notion of working together. And it's very pleasing to see that the airship industry is pulling together. Certainly we have a vote of thanks to Flying Whales, HAV, and Zeppelin for the work they've done in bringing forward the EASA regulatory framework, which of course can be a pattern for the rest of the world. And we're also seeing efforts going on as in Canada with our remotely controlled vehicles. This is also the future for the airships. At least many of us are believing that, and it's not here yet, but that's part of where we're going for sure. It was also pointed out that regulations don't apply just to the vehicle. They do apply to the operations of the vehicle, the pilot certification, mechanics, testing, the air drones. There's a whole raft of things that are required in order to operate airships safely and properly within our countries, and that work is going on. It's pleasing to see that there is thinking going on about that and work going on. Perhaps the theme of this conference has been on sustainability, green transportation. I think what you've seen today in terms of the presentations, that everybody's moving towards zero carbon emissions. We may not get there off the first models. I mean, there's reasons for that in terms of making sure that things work and safety regulations and certification, but that is clearly the direction that everyone is going. And it's an important thing for the world in terms of freight transportation, because it is a source of a large amount of pollution, and the airships can be a solution for that. I think it's also worthwhile pointing out that, as Bob Boyd mentioned in a previous conference we were at, that the aviation is next only to nuclear power in terms of the amount of regulations and safety issues and things that go into it. So it does take time to get this right. And it is expensive. And we know that that is one of the barriers to the industry coming forward, but it's pleasing to see that that is certainly going forward. In my last couple of minutes, I just want to say the following, and that is, it's very rare to see the birth of an industry. And it's even more rare to see the birth of a new transportation system. At best, they come along maybe once every 50 years. And we've seen them from steam engines to trucks to airplanes to containers. And now it looks like this next one is the airships. But it's been a long gestation, 85 years since we had the last rigid airship in the sky, flying across the ocean. And it may be a few more years before we see the next one, but certainly the process is underway. We need a lot of doulas to help birth this industry. There's no question of that. And it isn't going to be an easy birth. We will see setbacks, no question of that, but we know the direction is positive. And not only that, it's necessary. As we saw in the previous webinar yesterday, there are so many needs that airships can fill that nothing else can really serve. And when you have a demand and a supply, ultimately they will meet. And I'm very confident that we will see this industry emerge and fulfill the dreams that many people have, and certainly those that I share personally. With that, I can see that I'm right out of time and right on time. So I would like to thank everybody, especially I'd like to thank the committee that helped organize this. I'd like to thank the university and the people who worked behind the scenes to bring this forward. I'd like to thank everyone who participated. And we are going to have an in-person live presentation in the fall. I hope many of you can attend. We'll be able to get into some of the more technical issues perhaps then and delve a little deeper into some of the aspects of the airships that really isn't possible to do in this format, but I know at that time we will. So again, thank you very much, everyone. Thank you to the presenters, everyone who took the time to make this happen, and we look forward hopefully to seeing many of you in October this coming year. Thank you so much.